Hey, Vlad here, devinsideyou.com. Welcome to another video. I recently made a short in which I said that my favorite Scala 3 feature is top-level definitions together with exports, which is technically two features. I also mentioned how this will improve programming in the large, even though usually these features are discussed when it comes to programming in the small. I also made another short in which I mentioned an export's limitation, which if not lifted has the power to corrupt future library design. In this video, I'm going to try to demonstrate what I meant in both of these shorts, so let's go and take top-level definitions and exports for a spin. Before we begin, I have a huge disclaimer. Everything that I'm going to show you today can be very, very dangerous, so do not do this at home. Well, actually, this doesn't really work for programmers, does it? Do not do this at work. Only do this at home for your own project, okay? Today, we're going to collide entire worlds into one very carefully crafted namespace across libraries, apps, and entire projects. This can get out of hand very easily. Seriously, this is one of those I know what I'm doing situations. Jar hell is real, so you have been warned. Another thing that I would like to mention is that since I'm trying to demonstrate how these features affect programming in the large, we have quite a bit of typing to do. So I might end up splitting this video into two. If you're dying to see the next part, consider supporting me on Patreon and watch my videos as soon as I make them. All right, so the plan for today is simple. First, we're simply going to see how these features work, and then I'm going to walk you through a couple of scenarios of how I intend to use these features in large code bases. Also, there will be a sneak peek to the upcoming Zio series because guess what? It's also a Scala 3 series. So stay tuned, click the bell, and all of this nonsense. All right, so we're going to set up two projects right away. One is going to be a library, and the other one is going to be the application that is going to depend on this library. As in most of my videos, I'm on Windows, but I'm using WSL2, which currently runs Ubuntu 20.04, and I'm also using Windows Workspaces, so I can go back to Windows like this, and then go back to the Ubuntu WSL distribution like that. So let's go into my dev folder, which currently has only the Zio application that I just mentioned. We're going to touch it a bit later. So let's use one of my generate templates, not this one. We need the one for Scala 3, and I'm going to call it simply library, and I'm going to say that my organization is going to be com.lib, and the package is going to be com.lib. I'm also going to create another one. I'm simply going to call it app, and recently I bought the insideyou.dev domain, so I can use dev inside you. There we go. So let's for now open the library. Yes, we can import the build. And while it imports, we can simply open the main file, and we're going to throw everything out because this is going to be in the library. Okay, so we're going to start by simply demonstrating that we can have top-level definitions like this. All right, so as of right now, we're seeing the error because the blue build is still important, but once it finishes, the error should go away. Now, before we continue, I would like to point out this thing over here because this is going to come up a lot in this video. In fact, this is part of the reason why I'm so excited about the top-level exports. Okay, so a long time ago when Scala was released, it was actually supposed not to only run on the JVM, but also on the .NET runtime. And the main language on the .NET runtime is C#. And C# also has packages, but they actually call them namespaces. And so Scala came with a syntactic sugar for namespaces. So behind the scenes, this is actually what is happening. Okay, so this is basically sort of like an object, but it's, it's actually a package. Okay, and there are curly brace. There's a curly brace over there, and there's a curly brace over here. Now, because we're in Scala 3, as soon as I'm going to save the file, I have configured it in such a way that it's going to rewrite it to the indentation-based syntax. But behind the scenes, it's exactly the same thing. Okay, so it's namespaces, and I really, really prefer it, and you're going to see later why, because it is very consistent with all the other scoping things. So the same things, with private things and with nesting and with shadowing works the same way for, vals, devs, lazy vals, even vars and devs, and I said devs twice, and the classes and traits, and now it's for packages exactly the same way. Okay, for example, if there was something that was private over here, and again, now we can have top-level definitions. So, for example, private val x equals 6. Then over here, I would still have the ability to access the x because because it's inside, right? It's like as if it was object. Let's just continue typing all the top-level definitions because for now, I just want to demonstrate what you can have as a top-level definitions, which is basically everything. Let me just finish typing this real quick. So you can have implicit vals. Okay, it's going to be a 5. Then you can have vars. All right, so this is going to be a 6. Going to have implicit var b1 int equals 6. We're going to have implicit var b2, which is a string, equals null, which is probably one of the worst lines of Scala that you can possibly write. Okay, so all of this is going to work. Now you cannot have statements, right? So something like this is not going to work. Okay, so you can have defs. Okay, you're going to have implicit defs. right, equals 7. The next thing is going to be types. You can have top level types if I spelled them correctly. Type E equals string. Okay, you can have extensions, right, in the old syntax and the new ones. So you can have implicit class. I'm going to call it string ops, private val self string extends any val like this. Let's have a bit of space, and we're going to have yellow. It's going to be a string, which is simply going to use the console yellow constant plus the self thing plus console dot reset. Okay, you can also use a new syntax for this, which is just extension space self string like this, and we're going to have def green, which is going to be a string, equals console dot green plus self plus console dot reset like this. And also you can have given instances, which are basically implicit vals behind the scenes. Given char a, you don't have to give them names, right? So this thing is going to be called given underscore char. We can actually demonstrate this. Another char, which is a char, is given underscore char. Okay, so this is the name that was generated for this thing over here. Let's see a couple of them in action real quick. So we're just going to have an object main, and we're going to do extends app like this, and we're just going to do print line A, and we're going to do B, C, D, and then we're going to summon. Whoops, we're going to summon a string. How did this happen? This was supposed to be a D. Summon a string. We're going to summon E, which is a string, if you remember. It's over here, type E equals string. Then we're going to do, let me just duplicate the line. We're also going to summon the char, and we're also going to do implicit class dot yellow, and we're going to do over here, we're going to do extension green like this. Okay, so we don't have a D, right? Okay, so let's just why don't we have a D? Hold on, A, B, C. Yeah, I forgot the D. So we can have a lazy val as well. D is 8, implicit lazy val D1, which is int equals 8, like this. Okay, so now we have all of them, and maybe we should start running it instead of publishing it. And as you can see, it works, right? So we have 5, 6, 7, 8. We have the null for string. We have the null again for string. We have the A for the character, and these things work, right? So the implicit class is displayed in yellow. The extension is displayed in green, as over here. All right, now let's actually remove all of this stuff except for these 3 things. So these are the ones that we're going to use from the app. Okay, so just remove them, remove this main method. It's not going to be required like this. And over here, there is no main method anymore. So we're simply going back to doing publish local. All right, so now let's go over here and actually open the app. And I'm actually going to grab it. And I'm going to position it over here like this. Okay, so we have the library over here, which is like this. Maybe I can actually even close the terminal. Okay, so we're going to have the library over here. We're going to have the app over here. No, not now, because I need to go to the build. Wow, amazing fuzzy search in VS Code. Okay, so we're going to go over here, and we're going to have the main dependencies over here. So we're just going to add the com.lib. Okay, and then we're going to add the library, and then we're going to add 0.10 snapshot. There we go. So now we can actually import the build. While it imports, we can actually open the main over here. And what we can do over here now, we can have the imports first, right? So we're going to do import, and we can do com.lib.library, and I configured my Scala 3 to already work the way it will work in Scala 3.1, where the underscore syntax is going to be not only deprecated but actually no longer supported. So I'm going to use stars instead of the underscores. Okay, and we also need to import the given instances like this. Let me save the file. Let me actually close the build. Let me actually open SBT as well. SBT like this, and scroll down like this. Okay, all right, so what are we going to do here? We're going to do implicit class yellow, and we're going to do extension green, and we're going to summon the char like this, summon char, and we're also going to summon the string. I didn't leave the string in there actually. Let's actually go and add a string. So let's do a given string equals hello world like this. Okay, so this is published, everybody's happy, and there we go. So we can do R, and there we go. We have our more space like this. Okay, so we have our implicit class, we have the extension, we have the A, and we have the hello world. No magic so far. Now that we've seen top-level definitions, let's talk about exports, which similarly to imports can also be positioned at the top level, which is kind of ironic. Most languages have imports at the top level, and Scala is kind of special because you can have imports at any level you wish. But for exports, it's kind of in reverse. Usually you would want to have them in some very, very local scope, and it's just a cherry on top that you can also have them at the top level. Now, what are exports actually? Well, they can be a little bit hard to wrap your head around them, but they don't actually need to be unless you tie them to imports, which I know is kind of hypocritical because this is exactly what I just did. Exports sound like they are the opposite or like the inverse of the imports. However, I believe there is a better way to look at them. Imagine for a second that the export keyword in Scala was actually called delegate. Whenever you export a term, the compiler will simply generate the same term in your current scope. So it kind of becomes yours as if you had defined it. And it will simply delegate the implementation to the original term. So if you export a def will be generated. If you export a val will be generated. If you export a given will be generated. You might find it challenging to imagine the use case for exports, and there are actually two. The first one is the one that we're slowly getting at. We're going to get to it in the next couple of minutes. It's the ability to transcend imports across multiple files. The second use case is the one that we will discuss a bit later, maybe even in the next video if I end up splitting this one into two. It's generally a good advice to favor composition over inheritance. However, in most languages, including Scala 2, inheritance is way easier in terms of the boilerplate that you have to write. So because it's easier, most of us end up using it. It's very hard to resist the things that are very easy to do. So whenever you're designing your own libraries, make the right thing easy to do. Don't fall into this trap. Let's actually see them in action. Now, currently there is a limitation that you cannot export entire packages. Let's actually go and show this. So we're going to do export. So we have a star over here and we have a given, and it literally says implementation restriction. Package library is not a valid prefix for a wildcard export as it is a package. So at least for now, we actually have to import all of these terms by hand. Okay, so we're going to do string ops. I'm going to do green. We're going to do given char, and we're going to do string like this. Okay, so now that they're all imported, and did I not call this one string? I did not call this one string. Oh, actually, I wanted to have an implicit val over here, right? So I actually wanted to have an implicit val string like this. Okay, so this is what I wanted to have. Okay, so now this thing should be fine. Okay, come on, and this is again metals thing. Okay, so this was actually a VS Code thing, not a metals thing. If this feels like magic to you, what actually happens behind the scenes is that we're just gonna grab this, right? So we're just gonna dump all of them in there, okay? And now the implementation for this one is simply going to be com.lib.library. Okay, we're gonna construct a string ops self, and we're gonna do yellow, okay? Then this one is going to be com.lib.library. We're just going to call the method green with self. Over here, this given char is simply going to be com.lib.library given char. And over here, this string is simply going to be implicit, it's going to be com.lib.library string, like this, okay? So this one line generates all of this stuff, right? Great. Now, I hope that you can imagine why this is more powerful than imports, because this transcends files, right? As soon as you have a line like this somewhere in your project, everywhere you are inside of this package, you're going to have access to this. Okay, we're actually going to demonstrate this later, but for now, let's actually talk about this limitation first. Let me actually remove that. We don't need this. Let's do this. And now the whole thing is actually going to fit into one screen. Now, because exports are so awesome, I believe everyone will want to use them, especially the library authors. However, because of this limitation, they might end up corrupting the design of their libraries, and they will be forced to go back to the cake pattern, essentially, which is what I'm going to demonstrate now. Let's actually go back over here and let's attempt again to write what I wanted to write in the very beginning. Okay, so I wanted to have a colon over here, and then this one like this, and then these guys like this. Okay, so this is the same code, and all I want to have is I want to have an object over here, and please, come on, why are you doing this to me? As you can see, SBT publishes this fine, and I'm actually going to go over here, and I'm going to put a star over here, and now this is going to be fine, because you can have this with an object, but you cannot have this with packages. Oh yeah, it's a given. I accidentally removed too much, so we actually also need the given. Givens need to be explicitly imported, like this. It still shows two problems. Where? Oh, because of this. So this was actually not an error. I forgot that we have tests over here. Okay, so delete permanently. We don't actually need the tests. Okay, so we're fine. It's all good. Okay, so I thought that it was Metal's fault, but it wasn't. All right, so let's actually go into SBT again. Let's start publish local. Okay, writing. Okay, let's go over here. Everything is fine. Let's go back, change it back to package like this. Same thing again. Like, why are you doing this to me? Okay, it doesn't matter. The point is that now it doesn't work anymore, okay? Because it's a package now. All right, let's revert this and go back over here. There we go. Now, objects are constrained to being in one file. So what you have to do is you have to wrap all of them into a trait, either individually or you can group them however you want. And we're actually going to do this real quick. And this is what a lot of libraries are doing. Libraries like cats or libraries like scala test, for example. Okay, so let's do this real quick. So we're just going to do this like this. And I'm going to do this like that. And for now, I'm just going to put them all into one big module. Like this. I'm just going to call this module. So this is going to be like this. And now over here, I'm simply going to say extends, and I'm going to say module. Okay, there's a reason why I'm putting this in into a different scope. Okay, now you cannot have any vowels in a trait, so I have to remove this. Okay, so now it's happy. Okay, so now I can actually go and create a new file. And I'm just gonna call it module. Like usually you would have like a module for each one of these. What just happened? What? Yes, undo. The hell? Yeah, so usually you would have a module for this one, and 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 then you would have a bunch of them over here, right? But for now, let's just have only one. And in fact, we can actually have it in one line because I decided to have only one. So we can go and we can actually go into lib, and we can create a new file. We're going to call it module. Okay, so now we're going to grab this whole thing. We're going to put it in here. Let's remove library. I actually wanted to move it over here into lib like this. And in fact, the whole library is going to move, right? So this is called main. It's going to move into lib. The library folder is not going to exist anymore. And we're actually going to go and we're going to rename this thing to library, right? So library is now going to be just an object. Done save. Library. Okay, so we're going to remove this thing. Okay, so now we're just going to do this. We're just going to do that. Okay, there we go. So we have module, and it's in comlib. We have the library, which is just an object. Okay, and if you have multiple modules, like multiple traits, usually you would have also a trait that mixes all of them. Okay, so you're going to have this, and then you're going to have that. Okay, so imagine having like multiple over here, right? Module 1, module 2, and so on. Okay, and by the way, this is called a selfless trait pattern. Whenever you have an object that all it is doing, it extends a trait which is called exactly the same way. Okay, and in general, like having a bunch of traits being mixed into the same trait into one big trait is called the cake pattern. We all know this. Let me actually put this guy down over here like this so you can kind of see both. Okay, now why does this limitation exist? Well, the documentation currently says, now let me read this out, if an export clause contains a wildcard or a given selector, it is forbidden for its qualifier path to refer to a package. This is because it is not yet known how to safely track wildcard dependencies to a package for the purposes of incremental compilation. And in fact, the same thing used to plague package objects back in the day. They would simply destroy incremental compilation. And ironically, the cake pattern actually has similar issues. In any case, let's keep our fingers crossed and maybe this limitation is going to be lifted in the future. Let's actually go and demonstrate why exports are awesome. So we can go into our projects, which currently compiles, and we can go and we can create a file. We're going to call it library.scala. And it is in the same package, and I really prefer to do it like this, like package dev inside app. In fact, we might even not need to have it in the app. Let's actually move it into just dev inside you. Like this. So we're going to do package.dev inside you. In fact, let's not do this for now. Let me do Control Z and do it like this. Okay. So what I'm going to do is I'm simply going to move this export over here like this, right? Now everything still compiles. So it sort of feels like as if we had stolen the entire library. And again, this is a VS Code versus Metals thing. It should just shut up because I already added an export and it should all be fine. Let's actually create a little bit more space over here. There we go. What this means is basically that we regenerated the entire library in our application. I'm not saying you should do this, but it's actually kind of really awesome. This means that you never have to import anything from this library ever again. The same as doing over here, right? So you can create a new file. I'm going to call it whatever .scala, and it is simply going to be like this. You're going to see in a second why I'm doing this, by the way, why I'm structuring, why I prefer namespaces to packages. Okay, so I'm just going to do val x, and now I can summon the string, right? Because I have access to this given thing from the library. In fact, it's an implicit val, not a given thing. Okay, so we can go over here, and we can go and we can print line whatever .x. Okay, and there we go, hello world. In fact, this is kind of old school. We actually don't need an object because we can have top level definitions like this. So we can just go over here and they can simply do print line x like this. Now check this out. In every file, I'm using this dev inside you and an underscore app. Dev inside you, I'm sorry, not underscore, but underneath I have app. In the library, I have dev inside you underneath app. Okay, check this out. The first thing that we're going to do is I'm going to click a plus over here, and I have an alias called GI, which is simply going to init a repository, right? And it's going to dump everything in there. Okay, so this is now a Git repository. So what I'm going to do now is I'm simply going to, first of all, let's close it. Okay, check this out. If I'm going to remove this thing and I save it, everything still works. You know, because I'm such a good citizen, I'm actually going to move this up to dev inside. Okay, I didn't have to change anything more. Okay, let's look at the diff, just this thing. In fact, let's actually make sure show you a couple more aliases. I have GAA, I have GCMSG. Most of them actually come from the ZSH extension, and I have an entire course about Git if you want to check it out. It's completely free. It's here on YouTube. Okay, so now the alias gcam, which is the one that I actually modified. This is the one that uses all of them together. So I can simply dump everything into the current commit. So moves library from app to dev inside you. In fact, let's actually do move because this is the convention. Okay, and now the alias GSH, which is just git show. So if I do git show, and it's going to show me the last one, and I'm going to scroll up like this. Let's actually do this again. Git show. There we go. Let's do this again. Git show. There we go. Okay, so this is how the change looks like. All right, I just moved it up. I just removed this. I didn't have to touch any other files. This is one of the reasons why I really prefer namespaces. Now, I hope that you understand why exports are more awesome than imports, but I also hope that you understand that exports are more awesome than package objects, which don't exist anymore in Scala 3, by the way, right? Because package objects cannot be extended. Imagine that you have a multi-build with two projects inside, the one at the top and the one at the bottom, and the one at the bottom depends on the one at the top. If they both use the same namespaces and you want to have a package object, you can only have one, either in the top one or in the bottom one. If you want to have two, you're going to have to rename them, or, at least one of them. And then you have to know that, this other package object exists with another name, and you have to import it and so on. Now you don't need this. Now you can have top level exports in the top project. You can have top level exports in the bottom project. They can all live in the same namespace, but there is a caveat: you cannot have the file with exactly the same name, right? So just come up with some naming convention. For example, I call them, exports from the top level, and I'm sorry, exports from the top project, exports from the bottom project. You're going to see this in just a couple of seconds. Before this, let me actually show you a small bug that I discovered that I actually filed. Let me click down over here. For some reason, the exports don't work for Java objects. Okay, so if we had import Java util UUID, right? Then somewhere over here, let's actually remove all of these. Okay, we could have print line UUID dot random UUID like this. Okay, works like a charm. If you have an export over here, then it's going to compile, but it's actually going to fail at runtime with a class not found exception. I filed this bug, and I actually have no idea what's going to happen to it, because if it's a limitation, then I expect it not to compile. However, if it's just a bug, then I expect it to actually work. Okay, tiny limitation. So in order to avoid this, you're going to actually have to do something like, if you really want to have this, and I actually will show you this in a bigger project. So what you can do is you can do type UUID equals Java util UUID, and you can do object UUID, right? And you can use the fancy new inline keyword, which is macros, which is simply going to inline this def for you, and you can call it the same way, right? Random UUID, and it's going to produce a UUID, and it's simply going to do java.util.uuid.random UUID. Okay, so you're basically creating these delegates yourself, right? The export should have generated exactly this thing, well, and all the other methods as well, but you can do it yourself, at least until this bug is fixed. Now let me actually show you how awesome exports are in a real life project. And for this, we need a bigger boat. And for this, we need a slight introduction. A couple of years ago, I wanted to make a video about the cake pattern, but same as right now, I needed a bigger boat. So I created a fully over-engineered toy CRUD app that would create and, it would CRUD to-dos. And I have written it in a very simple way with constructor dependency injection. And then during these, I believe, 3 videos, I moved the constructor dependency injection to the cake pattern. Then a year later, I wanted to make videos about tagless final. And so I took this app, I cleaned it up, and I have rewritten it to tagless final. Now, you guys really, really wanted me to work on a Zio playlist, which is coming soon, as already announced. And so now I did exactly the same thing. So I took this tagless final code base, I cleaned it up again, I updated it to Cats Effect 3, I updated it to Scala 3, and now we're going to rewrite it to Zio on camera. Well, not right now, during the Zio series. I have already rewritten it, obviously. And so what I'm going to do now is I'm simply going to open it and show it to you. And because it uses, I went all crazy, I went all in with all these Scala 3 features. I tried to use as much of them as possible. And obviously I used top level definitions and exports there. And this is exactly what I'm going to show you now. So I already have it over here. So it's in the to-do, and I'm simply going to open it with Visual Studio Code. Okay, so let me throw it over here. All right, so now we have a bunch of workspaces. Okay, so we have the library over here, we have the app over here, and now we're going to play with this gigantic thing over here. Now, I cannot assume that you guys watched all of these videos, so let me give you a teeny tiny introduction about the architecture. So basically, there is a core of the application, and I used to also have domain, but I simplified it. Okay, so I just moved domain into core. If you guys have seen those videos, okay. So I just have a core. Ignore this project for now. Then I have 2 ways to deliver the core of the application. One is just in a terminal, and the other one as a web app with HTTP. I'm using HTTP4S. There are also 2 ways to persist stuff. One is just with an in-memory implementation, and another one is with Postgres, and we use Skunk for this. And because of this, we have 4 applications, right? We have all the combinations. And because I have rewritten this to Zio, I actually needed to have an integration with the Cats ecosystem. And so there's a project called Zio Interrupt Cats, and I have created my own tiny project that depends on that. And guess what's inside? I'm going to show it to you in just a second. But basically, there's literally one file with a top-level definition of some type alias, and there is an export to Zio Interrupt Cats. I've actually generated a dependency graph for you guys with Bloop. Let me actually open it with, oh man, that's a WSL thing. I actually want an SVG, this one. I want this one. All right, let me go back like this, and I should have right click, and I don't have right click. Reload. There we go. Okay, right click, preview SVG. There we go. So this is how it looks like, right? So we have the core at the top, and we have the Zio Interrupt Cats as well. So this is why we have the 1 over here, because they're on the first level. Then we have the second level, which is the delivery and the persistent stuff, right? All over here, everywhere we have the 2. And we have the 4 main projects, which are on the level 3. Okay, very beautiful. Now that you've all caught up, let's actually take a look at some goodies. The first thing that we're going to do is we're going to search for import Zio star. And as you can see, this is exactly the limitation that I've been talking about, right? I have 26 files that have this import. This one export would have solved this for me, but unfortunately, I cannot have it. By the way, fun fact, most of you guys don't know this probably, but in Scala 2, actually, hold on, where do I have this? Scala C. Okay, in Scala 2, there was actually a flag. It doesn't exist in Scala 3 anymore, but you could do this. You could go over here and you could say Y imports, right? And you can't, if you have a Scala 2 code base, you can have this right now. I'm not saying you should, but I'm just saying you can, okay? So over here, you can control the default import. So by default, and you have to specify it again, by default, Scala imports Java lang and the Scala.predef, okay? So you can just go and add Zio over here, right? And then you're not gonna need this thing, right? It doesn't work in Scala 3, but it used to work in Scala 2. I don't know if they're gonna bring it into Scala 3. Probably they're rather gonna fix, they're rather gonna remove this limitation for the exports. Okay, let me remove this. There we go. All right, let me close this. Let me go back here. All right, so the next thing I'm going to do is I'm going to search for files that are called exports. And this is sort of like the convention that I came up with. I already mentioned, like, you cannot have the same file because, like, for me, they will be in exactly the same namespace. They will be in different submodules, but they will be in different, but they will be in the same namespace. And so I cannot call them the same way. It's actually not going to compile. It's actually good that it doesn't compile instead of, you know, failing at runtime with class not found or something like this. Okay, so let me actually open core exports, and let me also open the other one. This one, I'm going to put it down over here. Come on, like this. Okay, so as you can see, I will never have to import these things again. And by the way, the documentation for the export says that it doesn't currently work for the renames. And by the way, this is the new syntax for what used to be this, right? Like this. Okay, so this is a new syntax for the same thing. A lot of inspiration from Python is actually coming to Scala 3. Come on, why are you doing this thing to me again? There we go. Okay, so I never have to import these things. And again, look, they're in different sub-projects, but they're all in just dev inside you. They're all in just dev inside you. In fact, every single file over here, all of them, they are in dev inside you. Okay, because like the other ones, they have dev inside you and they have something underneath, and therefore they see everything that is in dev inside you, right? So I never have to import anything that you see over here ever again in this entire project. And check it out, I can actually see where this thing is used. It's used over there because I have a thing called domain inside of the core, and inside of delivery over here, I actually have another thing that is called to do, right? So I'm creating a name conflict, right? Because I have access to the to do that is defined in dev inside you, and so I need to distinguish them somehow. And I could either do over here dev inside you, or I just renamed it globally to domain, right? And it's nice and easy. And guess what? You can actually jump in there, right? Bam, and I'm over there in just a couple of seconds. I'm going to be over there. Come on, there we go. I'm over there. It actually jumped to the definition. Really, really awesome. Let's see if it's actually going to work with Scala util chaining. Let me search for pipe somewhere. So I'm going to go somewhere and I'm going to jump to definition. Okay, yeah. So it totally worked. It's all cool. Right, let me close this one again. And also this one. So I'm just gonna like walk through some of the places here and show you a couple of cool things. Okay, so I wish that I could have exported, you know, datetime formatter and, you know, local datetime, but I couldn't. So I ended up, you know, doing the same thing as I have just shown you for UID. Basically, I'm delegating this myself. Local datetime again is already benefiting from this, right? So I don't need to have an import to a datetime formatter over here, right? Because check this out. If I grab datetime formatter, I'm gonna search for it in the code base. Look at this. 14 files. It just saved me 14 imports. All right. Again, we have the inline def, which is the, you know, the macros thingy. The next thing that we're going to have a look at is actually at UUID. Now, if you have seen the series, you actually know that to do is parameterized. Well, not this to do, the to do in the domain, which is over here, right? So it is actually parameterized with the ID, right? So because we have like two ways to persist our replication, only when we use Postgres we inject UUID in there, and when we use the in-memory persistence, we actually inject just an integer over there. Which means that if I search for UUID, the only places where I'm going to see this is, can I actually collapse all of them? Actually open it like this. All of them are in persistence Postgres skunk, persistence Postgres skunk, persistence Postgres skunk, like all of them, right? Now, technically, you see the UUID also in the projects below, right? In those two main projects. Let me open this thing again. Preview SVG. Let's do this and let's do that. Okay, so technically, like starting from here, this guy also sees UUIDs and this guy also sees UUIDs, but you don't see it in the code. Okay, actually, let me show you why you don't see this. First of all, let me actually open UUID because I did exactly the same thing, right? So I don't even have to import UUID anywhere. Now, this happens because we have a thing called parse. This parse is basically just extends a function. Okay, it's a function from some type to some other type, you know, or a throwable, right? It's in an either. Now, if you have seen the series, that you know that we have two implementations, you know, one that would parse an integer and the other one that would parse a UUID. And we used to have a companion object for this trait, and we would have both of them over here. However, I decided that I don't want to have them over there, right? So if I search for parse UUID, parse string to UUID, it is over here now, right? So it's at the bottom, right? It's a top level thing, okay? Because you can have a top level given definition over here. Look at this, no imports to UUID, no imports to cat syntax all, because we're using catch not fatal from cats. In fact, there are so many things going on in these two lines, right? We have a top level given, we don't have any imports, we're using a SAM type, right? A single abstract method type, right? Parse only has one single abstract method, which is apply, that comes from function 1. So we can use a lambda to actually implement this. And it is always visible. I never have to import some given, right? Usually you would have to explicitly import a given, but because my entire application lives inside of the dev inside your namespace, I never have to import it, right? So my dependency graph will make sure that everything that is underneath is going to have access to this. Let me actually show you one of the dependency graphs. Let's grab like this one for HTTP. Okay, so over here, right, this make method, it actually wants a parse from, well, I can't move my cursor when I do this. It actually wants a parse from string to do ID, but I don't have to import the instance. By the way, in this case, to do ID is a UUID, which you actually don't even see here because it is hard coded in the Postgres entity gateway. Okay, so if you go over here, you're going to see that. And by the way, sometimes it jumps into the wrong one. Okay, this is actually the right one. Okay, but over here it is actually hard coded to use the UUID. Oh, I just noticed a comment over here. How does this compile? Because usually with Zio, you would do Zio dot for each, right? And you would do to-dos, and over here you would have insert one. Right. So my question was, how did this compile? But it does compile because I have this cats integration, right? So I can actually keep using this thing. In fact, I'm going to leave this. I'm going to mention this again during the Zio series. And by the way, this is the point in the video when I would like to coin the term location-oriented programming, because I suck at marketing. And what I mean by that is that imagine having a code base where your code only compiles if and only if you put it in the correct place. Can you imagine how awesome this would be? Now, I'm an idealist. I know that this is never going to happen. And even though like this is a very, very clean code base, you can always like put some duct tape and, turn things around, turn things upside down. Still, it's actually getting very, very close to the right thing, right? So if you want to work with UUID, it's only going to work, starting with, Postgres skunk, right, over here and below, right? So it's only going to, you can only work with, well, UUID is actually a bad example because it's actually in Java util, but yeah, like unless you explicitly import it, it's only going to work if you use it over here, and over here. It's not going to work anywhere else. Imagine if you were using Mongo, and over there you would use actually object IDs. These object IDs, they're not in the Java standard library, so you could make sure that only over here you're going to have a dependency on some Mongo library, and then you would literally you would not even be able to import things over there, okay? And over here, you also are never going to need to import it because you're just going to have like one export at the correct place, and then you're never going to have to import it again. It's just going to magically work. Now, as already mentioned, there are huge caveats to this, jar hell, and now you have gazillions of implicits all in this one scope. So it takes a little bit of, very careful, care and actually craft to make sure that this doesn't cause any any big issues. But it actually also has even more benefits. It actually enforces you to properly fix your name conflicts instead of using the rename imports, because as I already mentioned a couple of times, those renaming imports, they're designed to resolve conflicts in your libraries, not in your applications. All right, let's see what else is left. So for example, over here, the only thing that I have is another type alias, right? So this is just a top level definition for a type alias, and let's see, right? I use it in 14 files, right? Top level alias, no need to import some util thing or whatever, wherever you're gonna put it, right? Top level definitions and exports are my favorite feature in Scala 3. And another thing, check it out. Even though we have core exports, right? So we already have a place where we have all of the exports in core. Let's check out the tests. In the task, we actually have a thing called a test suite. And look at that, it has more exports. Things like arbitrary and things like gen. I never ever want to import them again. I simply want to go and write my arbitraries. In fact, I have a file called to do over here where I have 2 top level arbitraries, right? Look, 0 imports, always available. Any test that I write, and it's at the top, right? It's in core. So wherever I want to write a test that would generate to-dos for me, I can without any imports. It's just gonna work. Let's actually have a look at one of these tests. over here, right? Somewhere over here for all over here, we're using this arbitrary, right? It just generates this to do and everything works out just fine. Let's look at the imports over here. Wow, only 0. In general, let's actually look at, let's actually look at where I'm using the import, space, and maybe like this, okay? Still, right? Still like 38 files. Okay, well, SBT doesn't count. SBT doesn't count. And this is still SBT. Okay, there we go. 34 files. Like most of them are 0. Okay, I'm not gonna go and click on 0. Right? So like the biggest one is over here in the test suite, and mostly it's 0 as companion objects. Like I do this very often. For example, like I have a class that I wish that I could collapse, but I can't for some reason. Okay, so I have a class, and at the bottom I have an object over here, right? And I import the object in the class. I do this very often. What else? This one I use it only in one place. That's why I did it. Over here, like again, I use it only once, so I didn't do it. Over here, I actually have to import a given. That's interesting. So I'm in a test suite, and over here, I'm using the type polymorphism to, I'm using the parametric polymorphism to actually insert a given for, I'm actually using unit for an ID, and therefore somewhere at the bottom, I actually need to have an instance for, you know, that knows how to parse a unit, a string into a unit, okay, just so that my tests work. This is the only place where I actually have to import, import a given. Then there's HTTP stuff, right? So I'm only importing this. Now, I'm sure that I've forgotten to show you a couple of things here and there, but if I did, I'll show them to you during the ZO series. And I've been recording for more than an hour, so yeah, probably this is where I'm gonna end this video. I'm gonna see you in this second part. As always, it's Vlad, devinsideyou.com. Don't forget to like this video if you did, subscribe if you want to improve the developer inside you, and if you learned something today, consider supporting me on GitHub sponsors or Patreon, whatever you prefer, and that's watch my videos weeks and sometimes even months before everyone else. And most importantly, take care.